All right, trig substitution. This is question number 2 from your notes package here. And we're going to talk about this. Somebody want to grab that door maybe? It's a little loud there. So we have the integral of 3 over x root 4 minus x squared in the denominator as well there, dx. So you might see this also written like this, right, with just the dx up top. I don't know. Sometimes you might see that. So don't be alarmed if that's true. This is the same as, being down here like this, right? Yeah. Okay, so what we want to do is we want to look at our formats and find out which one we might want to use. So this is a squared minus x squared underneath the root sign, right? So if we go back to the beginning of our notes from yesterday and we take a look at this right here, that's going to help us determine what kind of substitution we're going to make, right? So let me get back to the question here. So if I put this right here, which format do we see here? And again, we see this not in the numerator, but in the denominator here, right? So what format do we see? A minus x squared, right? A squared minus x squared. So that's the sine trig substitution there. So this is the one right here, right? Okay, that's all right. Now it's in the denominator. We've been used to ones in the numerator, so we'll have to see if this one has some slight differences as we move through, which I think it will. But nevertheless, what we do is we take our a, which is 2, right? This is actually 2 squared minus x squared, so a is 2. So I'm going to substitute. I'm going to let x equal 2 sine theta. All right, you okay with that? 2 sine theta. Now, if x is 2 sine theta, we should probably find out what dx is because I have dx in here, and all of a sudden this x stuff is going to turn into theta stuff. So I need to figure out what dx is. And so that's going to be 2 cos theta d theta. Okay? So now I can simplify this part, and as well, I can rewrite this x as well. Okay, so let's go ahead and do that. So this is going to be, it's going to be 3 on top, and we're going to have on the bottom 2 sine theta instead of x. Okay, and then we're going to have square root of, it's going to be 4 minus, what is x? Well, it's 2 sine theta. That's going to be squared. And then dx is actually, I'm going to put it up here just for room, but 2 cos theta, and then I'll put the d theta down here. So I just put this over here and here. Okay, so just take a moment, take a look at that. Let me know if you have any questions about that. We're going to, of course, do some more simplification. That looks like it's way more complicated, but you'll have to trust me that we're going to have, we're going to have a cos come out of here, right? Some kind of cos. We're going to be able to combine some numbers and pull those out of the integral and stuff like that. So let's go ahead and simplify some more. So this is going to be 6 on top, 6 cos theta on top. Down here is 2 sine theta on the bottom. And then this is going to be what? Square root of 4 minus 4 sine squared theta. D theta. And of course we're gonna work on this right here. I'll just maybe do it off to the side to save myself a little bit of room, but that's going to be the square root of, I'm going to take a 4 out, that's going to be 1 minus sine squared theta, right? Which is going to turn into root 4 is 2, and this over here is going to be root, that's cos squared theta. So this is going to be 2 cos theta. Now, we learned about that yesterday. You guys are still good with that? Okay, any questions about that? Okay, so this whole thing is actually 2 cos theta. So let me rewrite this one more time. I can do 6 over 2, I think. That'd be a good idea. Just make that a 3 cos theta. I have sine theta down here. And this is actually times 2 times cos theta, d theta. All right. So I'm going to be able to take a 3 over 2. So I got a constant here and a constant there. That's going to come out of the integral. So let me just skip down here. This is going to be 3 over 2 times the integral of cos divided by cos. That's gone, right? And that's going to be 1 over sine, which is what? Cosecant theta d theta. Okay, so we have simplified this significantly. If you compare the original question, Let's maybe zoom out a little bit. If you compare the original question up here with this right here, that's significantly simpler. So if we find the integral of secant, do you see it down here? Oh, that's not it. Integral of secant. Am I secant? No, cosecant. Well, here's cosecant squared. Do I have an integral of... Oh, here we go. Integral of cosecant. Now, this I have a formula for. I don't have a formula for the other one exactly, right? So this is not necessarily intuitive. You might not remember this, but we're going to use this integral right here of cosecant x. So that's going to be ln of absolute value of cosecant theta minus cotan theta, and then plus c. So let's work on that. Okay, so this equals 3 over 2. Now what's the integral of cosecant? Well, it's this over here, so I'm going to write ln absolute value of cosecant, and we're in theta, minus cotan theta plus c. And we're just a little over halfway now. What we have to do is resubstitute. We have to substitute back because this question was all about dx. X is dx. So I don't want this in terms of theta, I want this in terms of x. So what we end up doing here now then is, again, taking a look at our right triangle. So a right triangle that we might draw would look something like this. Here's our theta. And if we go way back here, okay, to x equals 2 sine theta, that was one of our original substitutions. And so I can find out what sine theta is, and sine theta is x over 2. So do I have sine theta here? Not quite. But I have cosecant theta, right? So that's the reciprocal of sine, isn't it? So cosecant theta is going to be 2 over x, because it's the reciprocal. So going back to sine theta equals x over 2, remember SOHCAHTOA is a 90-degree angle, so opposite would be x here, and hypotenuse would be 2. And this is going to be the square root of 2 squared minus x squared, or the square root of 4 minus x squared. Oh, nifty. Square root of 4 minus x squared. Have that in the actual question. Okay, so that's going to help us determine what, well, cotangent, I guess. I still need to find out what cosine is. So cos of theta now is adjacent. So that's root 4 minus x squared over hypotenuse over 2. And now that I have cosine, I can use the sine from here and the cosine from here to build cotangent, right? Because cotangent is cos over sine. Cos divided by sine. So I have everything that I need here now to resubstitute this expression. So it's 3 over 2 times the natural logarithm of absolute value of, it's going to be 2 over x minus, and it's going to be cos over sine is cotan. So I've got root 4 minus x squared over 2 divided by sine is x over 2. And so that just simplifies that they're both over 2. So when you flip and multiply that, it's a 2 on top and a 2 on the bottom, so they just cancel each other out. So really, this is, I'm going to do another round of simplification just right here by erasing. That is 4 minus x squared over x. And then you want to add your plus k there. So let me just double check a couple of, yeah. Can you simplify that? You sure can. Do you have to? Not really. This is fine. But you certainly could go, you could combine like terms here, right? So you could go 2 minus root 4 minus x squared all over x plus c. And that would be your solution. Okay, let me put that all on the same screen for you there. Any questions? All right, so the next one here in your worksheet is this right here, the integral of, now if it just has a dx up there, obviously that's 1 dx, right? So 1 over root x squared plus 2x dx. So this is a bit of a wrench. This is a little bit different. This is very similar to something that we see there, but this is a little bit different. So what we could do here is, I suppose, if we try to factor an x out, what do we get? We get x times x plus 2, x times x plus 2. I don't know if that really helps us because we don't have, a squared minus x squared. So we don't have an x squared in there anymore yet. We like to have this x squared. I suppose that if we completed the square here, we could come up with a perfect squared trinomial. I don't know if you remember doing that. So we could do that. We could also do some u substitution in this question. So let me just show you what I'm talking about. If I change this bottom here to x times x plus 2, I feel like I'm zoomed out. I am. Okay. If I change this to x times x plus 2 underneath the root, I've got a bit of an issue because I don't have the kind of format I'm looking for, right? I don't have x squared plus just a constant here anymore. I have x plus a constant, and I don't, that's not going to work, okay? So we're going to forget about that. Now, if I complete the square here, well, let's just watch what happens when I complete the square. So I don't know if you remember how to complete the square here, but you take half of 2, which is 1, and square it, okay? So if I do that, and then I subtract the 1 that I added outside, I can actually rewrite this as a perfect square. Okay? So with this one, you have to complete the square, because this then becomes x plus 1 all squared. Okay, and how does that help? Well, if I rewrite this integral as 1 over x plus 1 squared minus 1 dx, then I could actually do a substitution here for x plus 1, perhaps, and put x plus 1 as u and do a u substitution. So we're getting around to, oh, did I forget it? I forgot a square root sign, sorry. Square root sign. Okay, because remember, if we had x squared minus a constant, that's good. So now let's do this. Now that I've got that far, we've completed the square. So you might want to jot that down in this question, complete the square. Okay, where you have an x squared and an x term there. You might say, hey, let's get it to this completed square look. Because now you're going to be able to say, hey, u, we'll go back to u substitution really here. U is u plus 1. Du is going to be 1 dx. And this then can be rewritten as, watch this, 1 over square root of u squared minus 1. And of course, we have 1 dx, so that just can be written as du. So completing the square is the key to this one. A little bit trickier, but if we complete the square, do you see how now we have, like from our previous example, see this thing right here? We actually have a format that we can use here. All right. So which one do you see? What do you see here? Yeah, we have x squared minus a squared. So this is the secant one, which we haven't done an example like this for. So I can actually make, it's going to be u now. Okay, it's going to be u. And this is going to be a little bit of a more complex one because we are going from x to u, and now we're going to end up with theta. So we're actually doing 2 rounds of substitution. So this is definitely our level 2 one here. But u now is going to be, so instead of x, this is u squared, right? So that's u. What's a? Well, 1 is a squared, so a is just 1. So u is secant theta. All right, so just as a reminder, we are in x here, now we're in u, and now we're going to be in theta. And we're going to have to come all the way back to x when we're done. So I've got 1 over u is secant, square root of secant squared theta minus 1. And that's going to be, oh, did we do, shoot, du is, I have to be careful here, I guess. What's the derivative of secant? Derivative of secant. Well, we can go back to our handy little chart here. We got all the derivatives and integrals we could almost ever imagine. So do we see secant here? What is it? Secant x tan x. Not sure if you remember that from Calc 30 or not, but secant x tan x. So secant x tan x dx. Sorry, du. All right, secant x tan x du. Okay, so my du is going to have to be replaced by all of this. So not just as simple as making that d theta. I'm sorry, what is this d? Wow. Give me a second. This is theta, this is theta, this is theta. Sorry. Okay. So du, which is this one right here, is going to have to be, we're going to have secant theta in there, tan theta in there, and then we can put our d theta. All right, so du right here becomes secant theta tan theta d theta. All right, this is a long one. This is going to be this is a bit of a tricky one, but not impossible. Okay. So I need to do some work here on the secant squared minus 1. So what is secant squared minus 1? If you remember from your, remember what that is? Okay, so if we have sine squared theta plus cos squared theta equals 1, that's where we start with the Pythagoras, right? Remember that from pre-Cal 30. Now, to get secant squared theta involved here, how do I do that? Divide by sine? Oh, because 1 over, well, divide by what? Maybe, if I divide by cos, don't I get 1 over cos squared? Isn't that secant squared? So I'm going to do cos squared theta, everything. Cos squared theta, yeah. So this is tan squared theta plus 1 equals secant squared theta. Now, if you didn't remember this, you might want to review these because it might be handy to have in your memory. But now I can change secant squared to what? Tan squared plus 1. And that's actually going to be quite handy. Watch this. I've got all this stuff up here. I'm going to have square root of tan squared theta plus 1, and then a minus 1 under there, d theta. So I want you to see that underneath here now, you see this? That's going to, these 1's are gone, and the square root of tan squared is going to be just tan. See that? Now, I'm not very good at following my notes, so let's see if I've majorly messed up here or not. Okay. Everyone okay with that last step? There's a bunch of new stuff in here. But hopefully now you can see that, hey, I've got a tan on top and a tan on bottom, so guess what? This is actually just the integral of secant theta, d theta. Yeah, so you remember, I think did we just do this on the last question too, right? Or no, that was cosecant theta. We need to do, we need to do secant theta.
How did we cancel that?
Oh, how do we cancel this? Well, these tan is a factor on top and a factor on the bottom.
Oh, no, the one above.
The one above?
Yeah.
So tan squared theta plus 1 minus 1 is the same as tan squared theta. And then the square root of tan squared is just tan. That's how I went from here down to here. Does that help? Okay, integral of secant. Integral of secant? Yeah, or cosecant. Which one are we looking at? Secant, I believe. Yeah. All right, here. So the integral of secant should be on your chart there that you can certainly use. And go back and plop that down. All right. So now I have the integral of secant theta is actually equal to the natural logarithm of secant theta plus tan theta plus c. So we've done two rounds of substitution here to get it to this, all right, which we can now integrate. So now that I've integrated this, my only problem is that I have the value of that integral in theta, and if you recall, the original question was supposed to be in x, see, dx. So I need to go from theta now back to u, then back to x. Okay? So I just got to trace my steps back, if I can do that. Okay? All right, so let's go from theta back to u. From theta back to u. Or can we jump all the way to x? Let's see. Well, u is x plus 1. Theta. So we have to go back to what is the relationship between theta and u, because we need to make that transition. So we have u equals secant theta. Okay? So I'll just work over here towards the right. So if u equals secant theta, that means that 1 over u is cosine theta. Right? So here's secant theta actually here, secant theta, right? So I could just substitute this for u, I guess. So that's going to be easy one, okay? And then the tan theta, okay, so tan is sine over cos. So I got cos, I got to figure out sine now, okay? So again, use your little triangle. If this is theta, and cos is 1 over u, that's 1 here and u here, right? Adjacent over hypotenuse. So ka, toa, adjacent over hypotenuse, 1 over u. And so if that's the case, 1 squared plus this opposite side squared is supposed to equal u squared. So opposite side squared is u squared minus 1. And then, so the opposite side is the square root of u squared minus 1. So now we're getting there somewhere. So now the sine of theta is actually, this is u squared minus 1. So sine theta is opposite u squared minus 1 over hypotenuse over u. So now that I've got sine and cos, I can divide those to get tan. So I'll flip that to black here. So tan theta is sine theta over cos theta, which is root u squared minus 1 over u all over 1 over u. And so those u's basically cancel out, and we've got square root of u squared minus 1. Okay, I did that kind of fast, but can you see how this tan, how it ends up to be this right here? So I've got tan and I've got secant. All right. So what we should do is we should substitute back in. So let's go back to u. So ln of secant we said was just u. That's awesome. Plus tan we said was square root u squared minus 1. Absolute value sign plus c. Okay. And now we need to go back to x. So what did we say u was? U was x, was it minus 1? Oops, let's go back. X plus 1. So u right here, u is x plus 1. So x plus 1 is u. So that's going to be a ln of u plus the square root of x plus 1 squared minus 1, which I think we can kind of work that all the way back actually to, oh sorry, u is x plus 1. Sorry, plus c, and we can simplify this. What's that going to be? That's going to be x squared plus 2x plus 1 minus 1 is just the square root of x squared plus 2x from our original question. And then plus c, and we're good. Boom. From theta to u, back to x. That was a hefty one. But that is correct right there. Okay, so let me go back to the very beginning of this question. This is a bit nasty, but we completed the square, and we got it into this format, which looks very similar to this one right here, x squared, or yeah, like x squared minus constant. And so here we've got something squared minus a constant. So we did a little u substitution. We were able to simplify a little bit, and then we were able to get it substitute again into theta and simplified. Then we were able to actually make that transition from integral to kind of solution, or find the integral, which was this one. And then the final steps were substituting backwards. So theta to u, and then u back to x. All right, any questions from the class here?
That was easy.
Wasn't it? No? Not feeling it? All right, here's the last one we'll do here before I let you get going on your assignment. This one's similar to the last one, I suppose. We do have an x squared plus 4 there, which is a little interesting. That might pique your interest just a bit, right? So what does that one look like? Let's see, grab that chart here again. Okay, so what's the format there? Do we see anything that's kind of relatively similar? Which one's relatively similar to x root x squared plus 4? Oh yeah, right. Well, it's a plus. Oh, this one. So this could be written as 4 plus x squared, couldn't it? Because it's a sum. So that might be kind of nice, 4 plus x squared there. All right. So I could probably change that around so it looks just like that. Might be your first step of work if you want. 4 plus x squared, and then it looks just like this one. So a here is 2 then, right? The square root of 4. Okay. So this little handy chart says I'm going to substitute. I'll use, what color should I use here? Red? How's red for you guys? Good? If you guys want to shut these lights off, you can. It doesn't bother me. X equals, so it's going to be A, that's 2, tan, and theta. Okay. Okay, well that's good. What about dx? So the derivative of x, what's the derivative of tan? Remember the derivative of tan? Yeah, yeah. So derivative, oh, I'm on the wrong side here, but yeah, derivative of tan secant squared x. Or in our case, that's going to be secant squared theta. All right? Okay, so remember we do, because we have a dx here, so we need to find dx, and we have x's here, so we need to find x. Okay. All right. So what do we get when we go ahead and substitute all this in? Well, we get 1 over, we have, actually I'm going to square this, so it's going to be 4 tan squared theta. That's what this is. Oh, I'm sorry, what? Oh, for this one, yeah, sorry, that's 2. You're right. We missed the 2 here. Times 2. Secant squared, 2 secant squared. Yeah, that's right, thank you. So this is going to be 4 plus 4 tan squared theta. Okay, and dx is actually going to be 2 secant squared theta d theta. So I'm up here, I'm going to put 2 secant squared theta d theta when I substitute that dx. Alrighty, that should be a 1/2, and that actually could come out of the integral. I'll get rid of that right away. I do have secant squared theta over tan squared theta. We'll be able to simplify that probably. Let's help ourselves down here. So I don't know how many steps of work you want to do all at once here, but that's going to be the square root of 4 times 1 plus tan squared theta. Do we know what 1 plus tan squared theta is?
1 plus tan squared theta is
Yeah, what's 1 plus tan squared theta? Didn't we do that up here just before? Oh, look at this. 1 plus tan squared theta is secant squared. So this is, whoa, come Nelly. So this is actually 2 square root of secant squared theta. Yeah. Or 2 secant theta. Look at that. We got rid of the radical. Awesome. I've got another 2 down here, and I've got a secant down here. Okay. Okay, and d theta. So I'm going to be able to do some more simplification because this still isn't a real handy integral. I'm going to make this 1 over 4. This 2 is going to come out there. And I can get rid of one of the secants, I guess. And I can actually also write secant as 1 over what? Cos theta? And what's tan squared? That's sine over cos. Or if tan squared is in the bottom, that's actually the same as cotan, right? Or cos over sine. Is that right? So sine over cos in the bottom becomes cos over sine. And once again, I'm blasting through my notes. Make sure I'm not missing anything that I'd planned to show you. Okay. So, yeah, so let's see. This is going to be, wait, what the? Cos over, was that right here? Where was I? Cos, it's cos over sine. What did I write? I think I wrote down. Cos over sine. That's what it is. Cos squared over sine squared. I forgot my squared. Okay. There we go. That makes a little more sense to me. All right. So now one of these coses goes with this cos. And I now have 1 over sine squared theta cos squared theta d theta. Yeah. All right. The reason why I wrote it like that, or cos theta, I should say. The reason why I wrote it like this instead of cos on top is to highlight this. And now what we're going to have to do, oh, my computer just crashed on me. Oh, really? Problem with the page. I don't agree. You're the problem. All right, so if we take a look at this now, and my computer crashed a little bit here, but this should be cos theta over sine squared theta d theta. And as I mentioned to you just a few moments ago, that this actually is a really good substitution, u substitution candidate. Because if I let u equal sine theta, du is cos theta d theta, which I actually have cos theta d theta. So I can let sine in sine squared here equal u. So this is good for u substitution. So this is going to be the derivative of 1 over u squared du. And 1 over u squared. Yeah. So yeah, again, we went from x to theta to u real quick, but we're going to get back to theta real quick. Then we'll go back to u, or to x. So this is 1/4. What's the integral of 1 over u squared? Yeah, minus, yeah. So this is it's a -2 So you add 1 to get to -1, and you divide by -1. So that's going to be negative, which I'll put in front of the 1/4 there, 1 over u, or u to the -1. And this is going to be plus c then, right? All right. And so u, real quickly, we can go back here. U is sine theta. So that's no problem. So -1/4, 1 over sine theta plus c. And how do I get back to x? Now let me go back here. And x is 2 tan theta, isn't it? Well, I need to find out what sine theta is. 2 tan theta. Well, okay, so if x is 2 tan theta, 2 tan theta from before, then tan theta is x over 2. All right. Sine. Well, tan theta is sine over cos. Theta over cos theta equals x over 2. Times cos. Yeah. So sine theta, let's see. Sine theta is x cos theta over 2. So the problem with this is that we got x and theta all mixed up here, right? So this is still going to be partially in terms of theta. No good. So we can't do that. Good try, but we can't do that. So instead, oops, that last part I didn't need to erase. Instead, we could go tan theta is x over 2, and that's where you go back to your triangle there. So here's theta, and what's tan? Soka toa. So opposite is x, adjacent is 2. Okay, so this is going to be 2 squared plus x squared equals the hypotenuse squared, or the hypotenuse is, well, let's just do it like this. H equals square root of 4 plus x squared. And so sine theta is going to be opposite over hypotenuse, x over root 4 plus x squared. And 1 over sine is root 4 plus x squared over x. So we have -1/4 times root 4 plus x squared all over x plus c. And that's pretty much your answer. If you want to simplify that to just kind of one term here, that would be great. So negative root 4 plus x squared over 4x plus c. That appears to be your answer. So these are pretty off the beaten path kind of integration, right? We are kind of at that stage where we're we're past the just look on the chart, integral of sine, that kind of thing. We have to start to kind of go off path here a little bit. So some of the tips that I wanted to show you today were that, obviously if you see any of this format, any of this, you know what your substitution is going to be. But once you do your substitution, you might have to do some simplification, like we did here. Then you might have to either look at an integral chart, like these, to help you out, if you get it down to like cosecant or secant or even sine squared, whatever. Or you might have to do the old u substitution that we've done months ago. U substitution, which is the case here. And in the case, let's see, previous that was just looking at the integral chart. Yeah, integral chart. Okay, so again, integral chart, U substitution might have to be the order of the day too. Okay, any questions about that one? That's a long one.
So what's the final answer?
Final answer was right here.